Imagine living like that, without seeing clearly, depending on it to carry out daily activities.
This is a situation that about 1 million people live in Spain.
People with visual impairments suffer from orientation problems, limitations in everyday tasks, physical risks, etc.
Although there are solutions such as cans, guide dogs, and tactile pavement, and even initiatives such as Navilens and Be My Eyes,
Simple and dynamic orientation remains an undeveloped area, especially in pre-adapt urban environments.
Hello, we are Manabe Kaika, and our goal is to help affected people by some degrees of visual impairment by improving their orientation in urban areas.
Talking with different experts and people who had these disabilities, we realized that most felt really insecure when moving in unfamiliar environments.
Not only that, but the lack of adaptation to their needs in most of the cities increase their dependence and limits their autonomy.
That's when we come in. To see how we can solve this, we searched out what types of technology were easiest for them to use when moving. The one that stood out the most was
UHF AirFit technology
for its simplicity and accuracy.
We also studied in detail which colors and sounds are easy to perceive so that the information is clear, fast, and useful for the daily life.
All of this relates to the Sustainable Development Goals, especially the SDG 10 to help reduce inequalities and the SDG 11 to create safer, inclusive, and more accessible cities.
With all this, we created ODI, Orientador Dinámico de Información del Espacio,
a portable device designed as an accessory for phone cases, which reads the information programmed in UHF tags.
These tags do not need to be connected to any power source and are distributed throughout the urban environment.
The UHF reader describes the environment by reading the tags and sends the information as audio to our app, from which the notifications can be adapted to the user's needs.
Does this ring a bell?
Our project is inspired by the Navilens system, which uses colored QR codes that the users must scan to obtain basic information about the space around them.
But we have improved it!
Thanks to our app, it's no longer necessary to scan with a phone camera. Simply approaching is sufficient. This increases user safety.
In addition, it offers real-time auditory information through APIs and can be applied in schools and public spaces such as transportation. It will also serve to warn of potential hazards such as stairs or uneven surfaces.
To create the initial prototype of ODI, we used different technologies, App Inventor to design and program the app,
and AutoCAD and Tinkercad to create the design of both the casing and the 1:100 scale model, manufactured to present the project better.
ODI can be sold not only as a standalone system, but also as an extension to existing applications.
Of course, navigation applications such as Google Maps or Waze may be interested in adding ODI to their services, thereby also reaching our target audience.
Not only that, but city councils, schools, and companies may also be interested in our project.
In fact, we promoted accessibility in our own community by implementing ODI in our own school.
With ODI, we not only want to improve mobility, orientation, and accessibility for people with visual impairments.
We also want to help all our users feel safe, capable, and independent in an increasingly advanced society.
ODI!